This is the video for week 5, day 2. And today's topic is over functions. So let's start with problem number 1. So first of all, what are the directions for the problem? The directions are to determine if this relation I wrote here determines a function. So function or not function. So it's asking the question if this is a function or not. And so this here is called a relation. The left side is represented, or this left side represents the domain, and it just consists of the letters C, N, D, and W. The right side, as you can see, represents the range, and this is denoted by the letters Z, E, U, and N. So how do we know if this relation represents a function? We can use these following rules here that I've written down. The basic idea is as follows. If the domain has any repeats, that is, if some element appears twice, then this relation does not represent a function. If there are no repeats in the domain, that is, each letter appears only once on the left side, then this relation is a function. So for these kinds of relations, we don't even need to look at the range, we just need to look at the domain. So let's see, can we find any repeats in the domain? Well, you can see the letter C appears once, the letter N appears once, and so do D and W. Each letter in the domain appears once. So what we have is this situation here where there are no repeats in the domain. Therefore, this relation here is a function. So our answer is function. Let's look at the next example. Here we're given the relation, which is just a collection of points. That's what a relation is. And we want to determine, same directions as 1, is this a function or not? So the challenge in this one is determining the domain. So what is the domain if the relation is represented in this way? The domain is represented by the left coordinate point. So I guess you can say the domain equals a left coordinate point. So in that case, you have a 6, a 6, a 0, and a 0. And so if we want to determine if this relation is a function, we need to know if there are any repeats in the domain. So if there are repeats, it's not a function. If there are no repeats, it's a function. So let's see. Just look at the first 2 coordinate points here. In the left side of this one, we have a 6, so that means the element 6 is in the domain here. But we see the element 6 appears again in the left side. So we have 6 appearing twice in the left side. So that means 6 appears twice in the domain. In domain. Which means the number 6 is repeated. So by this row here, the first one, we have a repeat in the domain, 6 is repeated twice. Therefore, this is not a function. So our answer here is not a function. Because as you see, the left side of the coordinate being the element of the domain, 6 appears twice. And you can also see the 0 appears twice. So you could also have a 0 being twice, and it's not a function. Okay, let's move on to example 3. This is another way you can represent the relation with domain and range. So in this case, the domain, we have C and X, and the range is -8, -3, -9. The reason I picked this example is because it can be a little bit tricky, possibly. Again, we need to look for repeats in the domain. So a person might look at this and say, well, C appears once and X appears once, so therefore it is a function since C appears once and X once. But you have to be careful here because of these arrows. So in this case, we do kind of need to look at the range. So what this really is the following. If you write it all out, we have C goes to -8. Right here, D for domain and R for range. We have that C is also going to -3. And we have that X goes to -9. So this relation here on the left is actually represented by this. And if you notice here, we have the letter C appears twice. So we have C here and C here. So we actually do have a repeat in the domain. So C is repeated twice. Therefore, we have a repeat in the domain. By this rule, it's not a function. Something appears twice in the domain, it's not a function. So this is not a function. Okay, let's continue and look at more examples. So for example 4, we're going to look at the vertical line test. What the vertical line test is useful for is if you're given a relation that is represented by a graph. The idea of the vertical line test is the following. If every vertical line we draw through this graph intersects only one point, then this is a function, or 0 points. If there is a vertical line which intersects 2 or more points, then it's not a function. So let's look at the first one here. I'm going to draw a vertical line, let's say through here. As you can see, we have one intersection point here on the top line, and we have one intersection point here in the bottom line. So what we have is a vertical line that intersects 2 points on the graph. So 2 intersection points. And what the vertical line test says, if there's a line with 2 or more intersection points, this is not a function. So this first graph here is not a function. Now let's look at the second graph. Can we show that this is a function or not a function? Well, you can see if I try to draw any vertical line through here. So for example, I draw one through here, just one intersection point here. If I draw a line here, there's just one. You can see that if I draw at any point on this graph, I'm just going to have one intersection point. So there's always only one intersection point. One. So the vertical line test says if you draw a vertical line and there's either 0 or 1 intersection point all the time, then this is a function. So this is a function. So it passes the vertical line test because I cannot find a line that intersects the graph more than one time. Let's look at these next two examples. So let's look at the one on the left. Can we determine if this is a function or not? So right away, I'm just going to draw a straight line through the middle of the graph. And immediately we see 2 intersection points. We see one here and one here in the bottom. So we have a vertical line with 2 intersection points. And by the vertical line test, this says not a function. So we have 2 intersection points. Therefore, it's not a function. Now let's look at the relation on the right. So we want to see if this passes the vertical line test or not. So is it a function or not? So clearly on the left or the right, if you draw something, a line, straight line, you're just going to have one intersection. So you have one here. If you draw something a little to the right, you'll have one intersection. So these are no problem. But here is where there can be some confusion. So let's remember that the circle here, the shaded circle in the bottom, means that this is included in the function, the shaded circle. Just the circle with no shading means that this point is not included in the function. So a person might draw a vertical line here. So I'm going to try to draw through here. And they'll say, here's an intersection point, and here's an intersection point. So we have two intersections, therefore it's not a function. But this is why you must be careful. This point on top, we cannot count as an intersection. The reason being, because there's an open circle here with no shading. So this is actually not an intersection. The bottom one is. So this line only has one intersection point. So you can now see that every vertical line in this graph intersects only one time. So only one intersection for every vertical line. So what this means is that this graph passes the vertical line test, and it is a function. So let's continue. I picked one more example here to do, and this is how to evaluate a function. So we're given the equations. F of x is the square root of 2x minus 2, and g of x is equal to x over x squared plus 11. And we want to find the values f of 3 and g of 2. So let's look at f of 3 first. How do we find f of 3? Is you look at the equation for f of x, and every time you see the x, you replace it with the 3. So let's calculate this. F of 3 is equal to the square root. 2x becomes a 2 times 3. Then minus 2. 2 times 3 is 6, so this becomes the square root of 6 minus 2. And 6 minus 2 becomes 4, so this is the square root of 4. And the square root of 4 is equal to 2. So for our answer, we have f of 3 is 2. Now let's find g of 2. Like the previous example, every time you see an occurrence of x, you replace the x with a 2. So this equation, x over x squared plus 11, will become 2 over 2 squared plus 11. Now we can simplify. The 2 squared plus 11 will become a 4 plus 11. So we get 2 over 4 plus 11. 4 plus 11 is 15, so we get 2 over 15. And since 15 does not have 2 as a factor, this is in the simplest possible form. And so our answer is 2 over 15. Okay, so let's do some practice problems. So I picked a few practice problems. The first one here, I'd like you to try on your own. We have the equation g of x is minus 4x minus 3. And you need to calculate g of 6. And so here I've given you what the answer should be. It should end up being g of 6 equals minus 27. So your job is just to see if you can verify this and verify that this is minus 27. So that's your attendance problem here. I have chosen a few other problems, which I'd also like you to try, but I will also provide the solution if you get stuck or want to check. Number 2, we have the formula h of x equals the absolute value of 6x minus 8. We need to find h of minus 1/2. Problem number 3, we have the formula f of x equals 3x squared minus 3x. We want to find f of minus 4. In problem 4, we're given this graph of a function. So these blue dots represent the function, or it's a relation actually, not necessarily a function. The directions are to determine if this is a function or not a function with the vertical line test. So see if this passes the vertical line test or not. So please try these problems. And if you'd like to check your answers for 2, 3, and 4, you can keep watching the video and as I go over my solutions here. So let's first start on problem number 2. We have h of x is the absolute value, 6x minus 8. We want to find h of minus 1/2. So like the problem we've done before, this means if you find an occurrence, for every occurrence of x, replace with this number here, minus 1/2. So let's do this. We have h of minus 1/2 is the absolute value of 6x becomes 6 times minus 1/2. Absolute value minus 8. 6 times minus 1/2. This is going to be a minus 6/2. So this is the absolute value of minus 6/2 minus 8. Minus 6 over 2 is a minus 3. So this is the absolute value of minus 3 minus 8. By the definition of the absolute value, any negative number is converted to its positive. So the absolute value of minus 3 is a positive 3. So this becomes 3 minus 8. And 3 minus 8 is a negative 5. So this is negative 5. So for number 2, your answer should be h of minus 1/2 is a negative 5. Let's move on to problem number 3. We have f of x is 3x squared minus 3x. We want to find f of minus 4. So hopefully you've had time to work on this, and we can check the answer. So we want to find f of 4, a minus 4, just replace the x with a minus 4. So f of minus 4 is 3 times the whole quantity minus 4 squared. Make sure to keep the minus in the parentheses. Minus 3 times the minus 4. So here we have a minus 4 squared. A minus 4 squared is equal to a positive 16. So this is a 3 times a positive 16. Now what we have here is a minus 3 times a minus 4. So we have 2 negatives. A double negative is a positive, so we put a plus sign here. The number to the right is just going to be 3 times 4, and 3 times 4 is 12. So we get 3 times 16 plus 12. 3 times 16, you can check, is 48. And plus 12, so we have 48 plus 12. And 48 plus 12 is equal to a 60. So you should have for your answer, f of minus 4 is a 60. Now we're moving on to the final problem, number 4. Is this a function or not? Since we were given a graph, we just used the vertical line test. So if you draw a vertical line between the points, you're going to get no intersection points, so that doesn't cause a problem. If you take, for example, one of these points, so this one, you just have one intersection point right here. So far, no problem. So the only possible problem is right here where we have the 2 points, one above the other. So if I draw a vertical line through here, we'll have an intersection here and an intersection here. So what we have is a vertical line with 2 intersection points. And if you remember what the vertical line test says from earlier, if there's 2 or more intersection points for a vertical line, then this is not a function. So this is not a function. As you can see from this vertical line with 2 intersection points.